The Corona program pioneered the whole area of not only satellite reconnaissance, really, but the useful application of space.
Any failure that occurred in space, other than the Challenger blow-up, we did first.
When I look at what we did on Corona, it looks pretty good. But when you put it out in today's light, it looks pretty amateurish. But the whole country was amateurish.
This is the American space program that you know. Mercury, Gemini, Apollo. The familiar names of the pioneering efforts that eventually put men on the moon. But there was another space program you weren't told about. It was called Corona, and it was the world's first spy satellite. From 1960 to 1972, Corona took pictures that laid bare the secrets of the communist world. Born in the era of vacuum tubes and computer punch cards, Corona was a landmark accomplishment in engineering and espionage. But success did not come easily, and it would not have come at all but for the stubborn conviction of the men who built the satellite. They were from the generation stunned by Pearl Harbor and toughened by World War II, the generation that created the atomic bomb and then quickly learned to fear its power. Corona's story begins in 1946, a year after the bombing of Hiroshima. Under the codename Operation Crossroads, an elite group of scientists and soldiers gathered in the Bikini Islands to test America's atomic superweapon. Scrapped warships would be the targets of the world's first underwater nuclear blast. To record the devastation, the military sent in a dozen RB-29s filled with cameras and reconnaissance experts. Several men who later played key roles in Corona were on these planes. Camera designer Walter Levison was one of them. Levison spent most of World War II photographing enemy targets for bombing runs. He was not certain what to expect at Bikini.
I can't remember how many planes there were, but there were a lot of them, maybe 10, 12, something like that. And the whole side of the airplane was full of cameras. And we were warned, there's X number of seconds to detonation. And we had on very, very dark glasses. And we were not supposed to look directly at the bomb anyway, but what the hell was the point of being there if you weren't going to be looking at the bomb? So there's this beautiful, bright flash of light, and then the cloud starts growing. And there's a fireball. And it's immense. It's far bigger than you would think it would be. The ships that were anchored there were just tossed up in the air, and those are big, big ships. And they were tossed around like they were toys. And I think a whole bunch of us at that point turned their attention away from weapons of war more toward how do you prevent a war and what can you do. And that became the focus for the rest of my life, actually.
The threat of a Third World War emerged almost immediately after the Second came to an end. Two nations had emerged as superpowers, the United States and the Soviet Union. Their ideological differences were vast, and the political rhetoric between the two grew openly hostile. The Soviets made no secret that their goal was to liberate the world through communist revolution. Western leaders worried that the Soviets would develop nuclear weapons of their own and launch them against Europe and the U.S. in a massive surprise attack. The problem was, no one knew what the Soviets were doing. The nation was vast and mysterious, a brutal police state that punished those who asked too many questions. The exact size and strength of the Soviet military was known to few outside Stalin's inner circle. Conventional spying was useless. Aerial reconnaissance looked promising, but no traditional airplane could stay out of range of Soviet fighters and anti-aircraft guns. Forward thinkers realized the ideal vantage point for spying was outer space. Before World War II, the idea of even breaking out of the Earth's atmosphere was laughable. But Nazi Germany's V-2s proved that rockets were deadly serious business. Space was now within our reach. As early as 1946, Army scientists tested captured V-2s at White Sands, New Mexico. At the same time, the Air Force asked the RAND Corporation, a high-technology think tank, to study the feasibility of putting cameras into Earth orbit. But at this point, breaking the bounds of Earth's gravity still seemed a long way from reality. Working from other RAND studies, the Air Force turned to a much older form of transportation. Balloons had first been used for aerial reconnaissance during the Civil War. Now the U.S. hoped to turn them loose against the Soviets. In the early 1950s, the Air Force began converting its weather balloons, seen here, into high-flying reconnaissance platforms laden with cameras and listening devices. Eventually, hundreds of recon balloons were launched into the jet stream. Light-sensitive photoelectric cells triggered the cameras on at dawn and off at dusk. Codenamed Gopher and Genetrix, the balloons resulted in little solid intelligence, mostly because they could not be guided over specific targets. Test balloons also had the unfortunate side effect of fueling the nationwide hysteria over UFOs. Only 44 payloads were recovered from the 516 Genetrix balloons launched, and just 32 had usable photography. Still, one balloon uncovered a large nuclear refining facility in Siberia, so the program was considered a modest success. Genetrix's most influential supporter was Dr. Edwin Land, the inventor of the Polaroid camera and a fierce patriot. Land began secretly advising the White House on reconnaissance issues in 1954. Over the next 3 decades, Land and a small team of experts provided behind-the-scenes guidance on a slew of classified projects. That advice was urgently needed. The USSR had recently detonated its first hydrogen bomb. Eisenhower's fears of a nuclear sneak attack grew. He demanded information, but it had to be obtained as discreetly as possible. Land and his team suggested a short-term solution, building a controversial Lockheed design called the U-2. The Air Force had commissioned the high-flying plane, but they later rejected it because it couldn't carry guns or bombs. Now the U-2 would be manufactured and fitted with a powerful new camera and high-resolution film. But it would not be controlled by the Air Force.
At that time, Eisenhower had 2 institutions whose mission was security. One, the Air Force, and the CIA. Both of them were institutionally incapable of doing this job, the U-2. And I'll say the follow-on of the satellite. When I talk U-2, I'm talking overflight, U-2 satellite. When those 2 institutions, each of which alone was incapable of doing this, were brought together, we had 2 negatives make a positive. It created the U-2 and the follow-on reconnaissance satellite effort. The Air Force provided support, and the CIA, which really wasn't in the hardware business at all, carried the ball. And under Bissell did a fantastic job.
Richard Bissell was the CIA's point man on the U-2. Bissell had been the hidden hand behind the Marshall Plan to rebuild post-war Europe. His dealings with the Soviets left him convinced that the West faced an implacable adversary that would lie, cheat, and kill to realize its goals. He was determined to fight back by using America's technological know-how in the service of spying.
He had an unbelievable memory. He could recite train schedules from 10 years before. He did that just to keep his mind fit. He was a patrician fellow, very well educated, a man of great goodwill. He had come into the agency in Allen Dulles' time, and his first real project had been to develop the U-2. And he clearly was one of those people that just had a lot of get up and go. He could cause people to work together, he could build a consensus, and he was decisive.
Under Bissell's streamlined management, the U-2 was built and flown in 9 months. In 1956, it began its dangerous treks into Soviet airspace. Much as they tried, the Soviets could not shoot down the high-flying plane, but they did lodge diplomatic protests after every incursion. For this reason, Eisenhower rarely approved flights into Russia. But the photos the U-2 did bring back hinted that Soviet boasts of military superiority were more wishful thinking than reality. U-2 photos turned up surprisingly small numbers of long-range bombers. Nuclear test sites were found, but the size of the bomb blasts showed that the weapons were not as powerful as Soviets claimed. Soviet rocketry was coming on strong, but the threat did not seem overwhelming. Intelligence officers wondered if the Soviets were hiding all their significant installations somewhere in the USSR's vast northern territories. The problem was that the U-2 was not designed to take pictures of wide areas of terrain. At this point, balloons rose again as a reconnaissance option, this time under the name Weapon System 461L. Built around a powerful camera designed by optical physicist Walter Levison, 461L was an order of magnitude improvement in photographic quality for aerial spying. The camera could take sharp photos of wide areas of terrain from altitudes near the edge of the Earth's atmosphere, twice as high as previous balloon cameras. In 1958, after months of delays, 3 461L balloons were launched off an aircraft carrier into the jet stream. Unfortunately, the launches had been delayed, and someone forgot to reset the balloon's timers. All 3 payloads dropped into communist territory. Eisenhower was livid. The Air Force had guaranteed him that this new surveillance program would be undetectable. Now the president had an international incident on his hands. 461L was quickly canceled. But the elegance of Walter Levison's camera was noted by Polaroid's Dr. Land. It would quickly be put to new use. In October of 1957, the Soviet Union put the first man-made satellite into space. Soviet spokesman pointedly noted that the same rockets that sent Sputnik into orbit could easily send missiles to any part of the world. Sputnik set off a near panic in the United States. Politicians charged that America was lagging behind Soviet technology, and if action wasn't taken soon, the West would fall victim to a missile gap. In fact, American missile building was in full swing. The Air Force's Ballistic Missile Division had been test-firing ICBMs for years. Unfortunately, throughout the 1950s, U.S. rockets seemed plagued by gremlins. One of the programs managed by the Ballistic Missile Division was Weapon System 117L, a semi-secret plan to build a television-based reconnaissance satellite. Lockheed, the prime contractor, had made considerable progress designing a spacecraft called the Agena that would carry the TV camera into orbit. But Dr. Land, who stepped in to review the effort, decided that 117L was years away from delivering crystal-clear pictures. Remembering the powerful optics of Leveson's balloon camera, Land convinced Eisenhower that his new goal should be to put a similar camera into space, let it take pictures, then bring the exposed film back down to Earth for developing. The Thor rocket and the upper stage Agena spacecraft developed for 117L would be retooled for this new mission. It was a bold, quick, and relatively cheap solution. Eisenhower said yes, and a new satellite was born. It was given the code name Corona.
I was called into my boss's office, and he basically said, Jim, I'm going to give you a new assignment, which was a bit of a disappointment because I had the responsibility for the payload and most of the applications of this WS-117L, and I liked the job. I didn't want another job. But he says, we want you to go underground. And that, to me, after I found out more about it, was he wanted me to go off and head a covert program, a truly solid, need-to-know program that could tell no one.
The task facing Lockheed's engineers was daunting. At a time when American rockets could barely get off the ground, they had to put a finely calibrated machine into outer space and control its actions once it got there. The goal was to put a Corona satellite into polar orbit around the Earth. Once there, the satellite's camera would be turned on and off as areas of interest passed by underneath. The capsule needed to be stable on all three axes. In other words, instead of spinning like a top, it had to stay level like an airplane or a balloon, always keeping its lens pointed at the Earth. Corona's film would spin from the back of the satellite, through the camera, and into a take-up reel crammed into the nose of the spacecraft. When all the film was exposed, the spacecraft would eject a bucket filled with spy film back down to the Pacific Ocean. To carry off this high-risk plan, Eisenhower again turned to the CIA. Richard Bissell, now a rising star at the agency following the success of the U-2, added Corona to his list of responsibilities. Bissell applied the same tight security restrictions here that he established for the U-2. For Air Force coordination, Bissell turned to General Osmond Ritland, his deputy on the U-2 program. Ritland set up a covert or black Corona office, then hid it inside a mild-mannered space research program called Discoverer. Colonel Lee Battle ran the day-to-day operations of the so-called Discoverer program. At first, only Battle, his deputies, and one office worker knew the satellite's secret identity.
I was official United States Air Force secretary. The engineering stuff went right over my head. But I knew that I never mentioned NRO, I never mentioned CIA, I never mentioned any of these things in any conversation. I wouldn't even use the word black. Black program, what's that? The skunk works. You just never said those things. You have to be introduced to everybody before you do any talking. Like if I was introduced to you and I knew that you had been briefed, but I hadn't been introduced to you as this is so-and-so who's briefed on the Corona program, I could never discuss Corona with you.
A crash development program was set into motion. The goal was to begin launching satellites by 1959, less than a year away. Rocket engines were tested, and recovery capsules endured punishing trials to see if their delicate payloads would survive the shock of re-entry and splashdown. Meanwhile, Air Force pilots tried to learn one of the most challenging maneuvers in aviation history, catching recovery buckets as they floated down on parachutes. The public and most of the people who worked on the project were told that the Discoverer program's mission was scientific testing. These astromice were part of the deception. Discoverer was supposed to put them and a few monkeys into outer space. That never happened. But sometimes the satellite was used for legitimate research. When launches began, the secret Corona team often played a shell game, swapping in a science payload for a spy camera at the last moment. This cloak and dagger game frustrated the medical researchers, none of whom were briefed on the secret mission. Lockheed built the spacecraft, but a company called iTech built its contents, the first space-based spy camera. iTech was co-founded by reconnaissance expert Richard Leghorn, a veteran of Operation Crossroads. One of iTech's key employees was Walter Levison, the designer of the 461L balloon camera. Now Levison and a team of engineers wrestled with the challenge of building a precision instrument that could function in outer space.
What you want to do is to optimize the camera. The easiest thing in the world is to throw too much camera at a problem. And that means you put too long a focal length on it or too wide an aperture. And so it becomes important to be able to optimize the solution to the problem as opposed to throw the biggest camera you can fit into the space at the problem. You can put enough camera in there so it would never get off the ground.
I think anyone who knows anything about a camera is the worst thing that can happen is that you move the camera when you're taking a picture. And basically the problem is the same up there. While you are taking the picture, everything has to be standing still as far as you're concerned. Now, you take into account the fact that you are going 18,000 miles an hour through the area by what they call image motion compensation. And that's basically tracking the image with the camera system. But some changes can be so subtle you can't really identify what you've done. But if it works out, you better leave it alone and stick with it.
This elaborate maze of lights and miniatures is iTech's model room, where engineers test the sharpness of their optics. Since the days of Corona, lenses have been locked into this ceiling and pointed down at tiny targets. This system can replicate any possible angle of the sun at any time of the day or of the year. With a few minor adjustments, technicians can see exactly what a camera will see from outer space. But at first, no one was certain the Corona satellite would actually work. In the early days of spaceflight, basic questions about rocket science and optical physics hadn't been answered. For instance, could a camera survive being shot into space? If it survived and took pictures, would it be able to see through the Earth's atmosphere? Would the vacuum of space play havoc with the satellite's delicate parts? Would any of 100 other things go wrong? The answer to all of these questions was yes. If things could go wrong, they did go wrong. Vandenberg Air Force Base is the center of America's secret space program. Since the mid-1950s, thousands of rockets have blasted off from Vandenberg's 55 launch sites. Corona was just the first of a long line of classified payloads this base has shot into orbit. But Vandenberg is not the ideal location for a high-security launch site. It's often cold and foggy here. For several decades, a passenger train ran right through the base. Still, Vandenberg is in the right position to send satellites into the north to south orbits favored for spying. The base is situated on a remote tract of land next to the Pacific Ocean. A handy thing if you're worried about dud rockets crashing down on civilian heads. And in the 1950s and early 60s, rockets crashed more often than not.
Any failure that occurred in space, other than the Challenger blow-up, we did first. We failed in a marvelous bunch of different ways. We were always unhappy for the first 24 hours or so after a failure until we figured out what had happened, and then we went off and launched another, fixed it, and went off and launched another one. One that gets no publicity at all is what I call Discoverer Zero, and that was our very first launch, our first launch attempt, and we had the thing sitting on the launch pad, and we'd gone through the countdown, and we'd been very careful in the preparation to test everything, to make sure everything worked right. We pushed the automatic sequencer, and about 30 seconds later, technical hold. And what had happened was that there was a sneak circuit, and when we pushed the automatic sequencer, there were some little bitty rockets up on the Agena that were supposed to separate the Agena essentially from the Thor, and they fired. And they were supposed to fire when the Thor had burned out and you were up almost in orbit. Here we are still hooked up to the launch pad, and these things fire. It's not very good practice. The next one we launch, everything goes great. Yep, it takes off and everything is fine. This is Discoverer 1, and so the Air Force holds a big press conference and says Discoverer 1 is in orbit. Unfortunately, the tracking stations never hear it, nor does anybody else. But we've already said it's in orbit. And then we go back and look at the facts, and the facts are that our tracking station got only about half of the Agena burn, so it could only track it halfway, and it assumed that since everything was right halfway, everything continued to be right the rest of the way. Well, that's a bad assumption. And so we learned that you never say you're on orbit until you get acquisition at a tracking station. So we spent 3 weeks trying to prove that it went in orbit, and I'm convinced that, well, I signed the report that said it went in orbit, but I'm really convinced that it went in the South Pacific. Discoverer 2, we thought everything was going great. We made a mistake at the tracking station in Kaina Point. They misset the timer, and it was very easy to do. And we never could talk to it again because we were very paranoid about the Russians taking control of the satellites, so we only turned on the comm system when it was supposed to be in range of a tracking station. So it's gone. And so all we can do is sit there and say, where is this thing going to come down?
By studying the capsule's trajectory, the Corona team guessed that the film pod would land near the Arctic territory of Spitsbergen, perilously close to the USSR.
Did Discoverer 2 really go down in Spitsbergen? A bunch of guys jumped on an airplane and flew to Norway, and they were going to go out and see if they could find it. There was no way to get from Norway to Spitsbergen. There was no landing field on Spitsbergen that was big enough. So they flew over and they saw a lot of tracks in the snow, and they said, that must have been the Russians getting the capsule.
Luckily, Discoverer 2 didn't carry a camera. The mission payload was a pair of artificial mice, part of the biomedical cover story. Launches continued at the rate of 2 every other month. The rocket scientists and their military overseers were slowly inventing the craft of space travel and suffering failure after failure along the way.
We were very primitive. And sometime later, we blew up one. And the failure analysis said, well, the thing probably took off with a leak in the fuel tank, one of the fittings in the fuel tank, and it leaked out the hydrazine, and when the Agena ignited, the whole thing blew up. And so they said, we don't want to do that again. And so they said, you got to get a sniffer, a mechanical sniffer, to go up there and smell and see if there's any hydrazine. And there weren't any around in those days that could do it. And so we scratched our heads and so on. Lockheed scratched its heads and so on and so forth. And finally, there was a guy in Lockheed said, well, I've got a calibrated nose. And so everything's all buttoned up, and someplace in the count, after they've got a little bit of fuel on board, this guy gets up in a cherry picker, and they take him up, and he unscrews a hatch on the Agena, and he sticks his nose in and goes, all okay. So now today, OSHA, IRPA, and all those other clowns would die, but because it's poisonous as hell. I mean, hydrazine is not healthy stuff. We had 10 launches before I went to Vandenberg for a launch. And the launch I went to was a glorious failure. The Thor lifted off the pad, and they'd made a mistake. And instead of going straight up and going over like this, it went up, and it was a dancer. And they blew it up at about 20,000 feet. And here's all these pieces, and you're sure they're going to come down and hit you. So there was a mad scramble to get under something, and then suddenly somebody realized that thing's going to fall down here, and it's got all sorts of classified stuff on board, the film. And so there was a mad rush, went down, jumped in the car, and drove like madmen down to where the thing was, and over in one corner, off in one area, there was the payload. And the front end was relatively intact, and so we didn't spread film all over everywhere.
Eisenhower was very clear as this went along. He said when I would report to him another failure of the so-called Discoverer satellite, he would say, don't worry about it. We're going to stay with this thing. We're going to bring it through because it's something that we really need. And he was committed to it and very steady in his support.
Finally, Eisenhower's patience was rewarded. With Discoverer 13, the Air Force and Lockheed managed to put a camera into orbit and turn it on and off. The payload bucket was ejected right on schedule, though this test mission didn't carry any film. The falling capsule eluded the recovery planes that hoped to snatch it from midair. The bucket splashed down 300 miles northwest of Hawaii, where it was retrieved by a Navy helicopter. An encrypted message was immediately sent to Richard Bissell at the CIA. It read simply, "Capsule recovered undamaged." The Air Force, Lockheed, and their shadowy partners in the intelligence community could now breathe a sigh of relief. The months of embarrassing failures seemed to be over.
When the Russians beat us with Sputnik, I think we could have beat them if we'd wanted to, and that's the Air Force had wanted to in the early days. But the Sputnik wasn't much of a program, and the Russian attempts to put the dog and all of that stuff in orbit, those were very well done, to be sure. But they weren't really trying to do what we were trying to do. We were trying to put something in orbit, do a job, and then bring it back. So that the big race for us was recovery. And when we finally did make recovery, we had a very, very nice party. And all of the key people to celebrate got thrown in the swimming pool at Ricky's in Palo Alto. That was our big celebration of that event. We were very pleased with ourselves. So we said we beat the Russians in that case.
There's nothing that we cannot pick up. That's my motto. I've lived it from 40.
Like many technological marvels, the mid-air recovery of the Corona capsule had very low-tech origins. The method grew out of mail pickups and drops used in World War II. Harry Conway, an Army Air Corps vet with CIA connections, was the most outspoken advocate of using planes for covert missions. In a series of demonstrations, Conway proved the technique by pulling crates from the sea and drone planes from land. To make his point that even delicate cargoes could withstand the stress, Conway himself volunteered to be snatched.
The aircraft comes in with this pole protruding, and it has a bronze hook. And when he makes contact, and of course he goes straight up, I mean, climbs to altitude. And like with a man, myself, I'm sitting in this same position, just like this. When they make contact, I raise up about 3 or 4 feet, and then you take right off. And their contact speeds are anywhere from, I think on a B-26 it was 106, and that's almost stalling speed. But I was picked up once with a B-29, and I took 59 Gs at that point. I had a hard time getting insurance.
Air recovery was first used for the secret balloon reconnaissance programs. After the camera payloads separated from their balloons, they floated down on parachutes. An air crew would throw out hooks to snag the parachute lines. Once snagged, the payload was then reeled into the back of the plane. The same technique was applied to plummeting Corona capsules. To keep Corona film from falling into enemy hands, a squadron of C-119s was sent to Hawaii. It took air crews months to perfect the satellite recovery technique. The trick was to figure out a falling capsule's trajectory, then to put airplanes near the capsule's path of descent. When the capsule appeared, the C-119 swooped in to grab the falling bucket of film.
I roomed with this Captain Bruton. He was captain at the time. So I says, Jim, what are we going to be doing out here? And he says, well, we're going to be recovering nose cones from outer space. Oh, Lord, came all this way to have a roommate that's a real wiseacre, you know. So that my reaction was very similar to most people's reaction when they found out we were going to snag capsules or parachutes out of midair with aircrafts.
Discoverer 14 was the first mission where everything worked correctly. The Corona camera took its pictures, the film bucket was shot back to Earth, then the bucket was successfully snagged in midair. But recovery crews were kept in the dark about the bucket's true identity.
I think that everyone speculated it on what it was, and of course that speculation was never discussed among people, and it was in the newspapers and you know, all this kind of stuff, what are the big spy satellites and things like that.
What happened if they missed? Consider the case of Discoverer 15.
We were, as I say, quite worried that the Russians or somebody would get this capsule with all the film in it if we didn't catch it, or if it fell in the ocean. So there was a salt plug in the bottom of the capsule. The salt plug was good for roughly 24 hours, supposedly 12 to 24 hours. And if you hadn't gotten it back by that time, it would the plug would eat away and the water would flow in and it would sink. And so that was one of the safety features on the doggone thing. And in this particular case, the capsule came down way long, and they got bunch of nuts that like to jump out in the ocean in parachutes and float around. And when they finally got them permission to jump, a cloud came through and it rained, and when the cloud went away, the capsule had sunk. And so we didn't get Discoverer 15 back, and that was a disappointment.
Technical problems continued to dog Corona over the next few years. But from the very first missions, Corona photographs opened up the secret world of the Soviet Union to an extent that CIA analysts could only dream of in the 1950s. Photo interpreters began the laborious but critical process of mapping and studying every square foot of China, the Soviet Union, and their client states. Within just a few years, the U.S. went from having only vague knowledge of communist strength to knowing the precise deployment of Soviet and Chinese forces.
It was revolutionary. In fact, imagery, in a sense, is what set the United States intelligence community apart in the world during the 1960s in particular. But almost no one can get in to a denied area. and with remote sensing, basically count the forces and develop the anatomy of the threat that's facing them. That was an American specialty until fairly recently.
But how would the Soviets respond to spy satellites? That question weighed heavily on high-level brows. In 1960, just prior to Corona's first successful flight, a U-2 spy plane had been shot down over Russia by a new surface-to-air missile. The intelligence community could only cross its collective fingers and hope that Corona would not suffer the same fate. ITEC's Richard Leghorn visited Moscow in 1960.
We were sitting there in the Hall of Friendship in the Kremlin, and the General Secretary of the Soviets Academy, who sat opposite from me, after 2 weeks with clouds all over Moscow, he said, "Leghorn, you're crazy." I said, "Why?" He said, "Well, you've been here 2 weeks now. Have you seen a ray of sunshine?" I said, "No." He said, "Well, why do you think you're going to take all these pictures from space?" I mean, they were tracking our satellites, of course, and knew the whole story.
On average, cloud cover ruined about 40% of Corona photos. The Soviets realized that the other 60% would yield valuable intelligence, but they decided to turn a blind eye to satellite overflight. The bloodless sport of surveillance was now acceptable so long as it occurred outside the Earth's atmosphere. Clouds turned out to be the least of the problems that faced camera designers. In the early 1960s, Corona's film often dried up and crumbled in space. This problem was eventually solved by the film's manufacturer. Kodak perfected a polyester-based film that could better withstand the arid conditions of space, where temperatures range from 250 degrees above zero to 250 degrees below. But the most maddening camera problem coincidentally shared its name with the satellite.
As it turned out, Corona was one of the biggest problems that we had in space. Now, Corona, for those people who don't understand it, is an electrostatic discharge which results in a spray of light. And you can't have that inside a camera, else you don't have any film when you get back onto the ground. So our ability to finally overcome that problem was one of the most important things we were able to achieve. And we brought everyone from the janitor to Ed Purcell, who was a Nobel Prize winner over at Harvard, in on the program. And we had finally come up with what I consider a pragmatic solution.
Eventually what Frank did, and this was Frank's idea, eventually what he did was he built a rig to steam the rollers. And then he took each one of them, put them into a camera, put film in the camera, put it into a vacuum chamber, and if he got static, he threw it away. If he didn't get static, we used it. And that's the way we solved the problem.
By the mid-60s, the quality of Corona imagery had improved dramatically. Resolution quality, the sharpness of objects in a photo, went from 25 feet to 6 feet in a handful of years. Corona data had already proved that fears of Soviet ICBM superiority were unfounded, though the photos also proved that the USSR was building up its forces in all areas, from atom bombs to chemical weapons. Chinese activity was also closely monitored, and by studying force-level buildups along their borders, analysts were able to watch the tension mount between the USSR and China throughout the 1960s. Later, President Nixon was able to leverage both communist nations against each other in the pursuit of détente. Corona cameras also turned up unexpected findings. In a strip of film shot over the Middle East in 1971, a photo interpreter saw a puzzling pattern in the sand. On closer inspection, he realized he was looking at a 12th century Roman fort that was invisible from the ground. Sometimes Corona shot color and infrared film, but the resolution quality was relatively poor. Color pictures were useful when analysts needed to monitor crop growth or mining activity. Perhaps the most dramatic Corona photos were taken in 1969, when the superpowers were racing to put men on the moon. The Soviets had built a 315-foot conical-shaped rocket, probably the largest rocket ever made. This is the rocket sitting on its launch pad, being readied for its first flight. And this is the aftermath of its disastrous launch. The rocket exploded on the pad, with a blast so powerful that its launch gantry and electrical tower were knocked to the ground.
There's so much information on there, you sometimes wonder, did they ever actually get everything you could get off of any one negative? And the answer is, in all probability, they did on the negatives of great interest, but that was, relatively few negatives.
This is Lockheed's Hivos test facility. Here, satellites are raised into a vacuum chamber and subjected to the extreme conditions of space. For more than 12 years, engineers used this room to put Corona satellites through their paces. As new technologies developed throughout the 1960s, they were quickly integrated into the spaceship.
We started off, we had vacuum tubes. And then we went to transistors, and we went to the more modern electronics and so forth. All the time, the reliability equation is getting much, much better. But to get a given transistor or a given mechanical system, like the camera, to run for that long, you pretty much have to go to some very, very special things. The first thing, make sure it's built out of very, very good parts. You can't just take any old run-of-the-mill Radio Shack parts and build a satellite. We had to get very, very excellent, good, clean parts. The second thing is you have to test them very, very carefully, make sure what you have. And then ultimately, you have to design in redundancy. So we called it belt and suspenders redundancy, so that if one failed, you go to another system to back it up.
This is the final version of the Corona camera, the KH-4B. First flown in 1967, this camera was fitted with 2 lenses and 2 film buckets, effectively doubling its useful lifespan. Stronger rockets also let the satellite carry 160 pounds of film on board, a 120-pound improvement. By the late 60s, Corona had flown well over 100 missions, but the satellite's useful life was coming to an end. Powerful new systems that didn't use film were on the way, but Corona's reliability and relatively low cost made planners loath to cancel it.
Corona was very early in the application of space for any purpose, and it did pioneer the recovery of payloads from space, high-performance imagery in space, 3-axis stabilization of camera or of space systems, all of which were absolutely vital. If they hadn't been done in Corona, they would eventually have been done some other way. But this was really the very fastest and the cheapest way to do it, even though there were an even dozen failures, so-called failures, where no film was returned with imagery on it. Yet at a cost of $7 million or so per launch, $850 million for the 145 launches, as I recall, that was a cheap price to pay.
Corona was the first successful U.S. space program, and it managed to outlive NASA's Mercury, Gemini, and Apollo programs as well. By 1972, when the last and final Corona satellite was launched, Americans had already wearied of men walking on the moon. But Corona's long-term legacy extended far beyond its technical accomplishments.
You know, we all felt a part of something that was going on that was terribly important to national defense and to national policy. And there was not the usual squabbling between contractors, and there was not the usual squabbling between agencies. You know, the CIA and the Air Force got along. And we were all working for what appeared to be a very important end goal. And we all felt pretty good about that.
This is the headquarters of the National Reconnaissance Office. A joint CIA and Department of Defense agency, the NRO builds and maintains the U.S. fleet of space-based spies. The agency is the institutionalized form of the partnership that began with Richard Bissell and the Air Force back in the days of the U-2 and Corona. Formed in the early 60s, the NRO was so secret that until 1992, even its name was classified. But now that the Cold War has ended, the agency is taking a cautious step out of the shadows. The Corona program has been declassified, and its pivotal role in the history of aerospace and intelligence gathering has finally been revealed. Recently, the NRO turned over all 2 million feet of Corona film to the National Archives. It is hoped that this detailed record of the Earth's surface will be closely studied by historians and environmentalists. Corona imagery is also being funneled into an effort that would have been unthinkable when the satellite was flying. A joint U.S. and Russian working group is currently exploring ways that both nations can use their collection of satellite spy photos to help clean up the environment. The satellite that answered so many Cold War questions may have yet another life, this time solving the peacetime puzzles of tomorrow.